Hi everyone, my name is Andrew and I'm going to give you lots of unsolicited advices today. I'm going to reflect on my industrial experience in Haskell. One big disclaimer is that my experience is small team Haskell in a huge corporation. So it's not an experience of like running a startup, which is 100% Haskell. It's not an experience of running a huge Haskell team like of 100 people, right? So take my suggestions with a grain of salt, please. And so when I started reflecting on what I think about how to write Haskell and what works well and what works not so well, I quickly discovered that my views are quite radical and quite the opposite of what I would expect from myself being an industrial developer, right? I try to rationalize my views and bring them into a sort of framework, right? Which we will call for now not so boring Haskell, but I will reveal the real name later on. If I revealed the real name upfront, you will probably leave the audience immediately, right? I asked organizers kindly not to have any tomatoes in the snack area, but there are plums, pears, and apples. Feel free to use them. No hot drinks. Yeah. And why I think that my experience again is that probably my working environment is kind of not so common case. Most of people who I talk about are using Haskell in like startups, yeah, or in a huge Haskell teams like we have at Standard Chartered, for example, right, when you have like dozens of developers. And that's quite a different experience. I think that my professional experience could be valuable if you try to introduce Haskell at your workplace as a first project of its kind, right? Because you will be in the same situation in which I was for the majority of my professional career, that you are like the only Haskellers in the corporation or in the company. Yeah, you're a small team, and you have all this pressure that you have to communicate to other teams and other systems and stuff, right? So the name of Not So Boring Haskell is obviously for old-timers a reference to Boring Haskell Manifesto by Michael Snoeman almost 6 years ago. Yeah, and Michael says that basically it feels like Haskell has two deeply overlapping subcultures. Yeah, one of which is like exploring interesting concepts in computer science, in mathematics, in engineering, and another subculture which is focused on like making better software or making software better. And Michael says that exploring like interesting concepts, enjoying yourself can be fun, rewarding, and huge benefit in long term, but he feels like in short and medium term it's actually a liability to your output. Yeah, and the claim is, or at least the suggestion goes, that probably a simple subset of Haskell language and ecosystem, yeah, can have a big benefit to cost ratio. Yeah, and probably we should focus on finding such small, simple subset of Haskell, which we will call boring Haskell, which will enable all industrial developers to like have the best of both worlds. It's been never clarified what exactly this simple subset looks like. Yeah, a month later there was a subsequent like simple Haskell initiative, right? Which again, you know, it's very difficult to get Haskellers to agree on anything. Haskellers are strongly typed, so when kind of you have two Haskellers and their types do not match, there is nothing you can do about it. So like, I've seen a couple of blog posts back then, and each of them been declaring their own version of what is simple and what is not simple, and none of them agreed with each other, right? So Simple Haskell initiative makes kind of a sidestep saying, okay, let's declare values. And our values will be accessibility. We are saying that fancy Haskell costs a lot to teams because it will take more time to understand. It limits the hiring pool. That our value is using mature libraries, prefer using things which have been there out for a decade, right? And our value is not to leak complexity, so if you decided to introduce something new, at least keep it well contained. Somewhat perplexingly, I find myself on the very opposite side of debate on this. Despite me having no background in computer science academia, and spending all my professional life as a very down-to-earth software developer, I disagree. Starting with basically boring Haskell manifesto. I don't really believe, maybe it's been more true in 2019, I don't really believe that at this point we have any sizable exploration in pure sense culture in Haskell. Haskell is no longer an exploration vehicle for computer science because while we have very advanced type system comparing to other, like, I don't know, comparing to Java, for example, right? There is nothing groundbreaking in dependent types. That's been all discovered and explored at least 2 decades ago, probably 4, right? Linear types, again, it's been well discovered and explored in academia decades ago, right? We are not an exploration vehicle for homotopic type theory, cubic type theory, or anything like this. There are other languages to do this, right? We are not an exploratory vehicle for proofs or anything of this sort. So I don't believe that at this point in Haskell history we really are exploring revolutionary concepts in computer science. Not at all. What we are doing in Haskell is actually productionalizing these concepts. We are turning these designs explored in academia, we are turning them into working tools, practical tools, so inherently making better software. We are kind of applying it. So I don't believe that there is a tension between 2 subcultures at all at this point. And also, I do not believe that limiting feature set is going to help anyone to make your code simpler. The reason is, again, that I happened to work with a legacy Haskell code base, and legacy means, in this case, 20 years old. And oh my God, it's been the most complex Haskell code I ever seen in my life. That's because people, long time ago, they didn't have fancy Haskell features implemented in GHC later on. But they did want to use fancy Haskell features. So they've been indeed doing some dependent Haskell stuff without proper tooling, without proper support from compiler, and ended up with a horrible mess of code. Yet by modern standards, the feature set was very, very limited. And that's exactly what caused them to produce horrible code. Going forward, I strongly believe that Haskell's unique selling proposition is that we offer people an opportunity to explore without sacrificing either reliability or time to market. And our core enabler for this unique selling proposition is that Haskell offers fearless refactoring, the most important feature of Haskell in my opinion. Turning back to a simple Haskell initiative and these declared values, again, I find myself opposed to basically all 3 of them. Because I think that curiosity is what has driven us to use Haskell in the first place. It's because of curiosity we are doing Haskell. And we should not be shy of this. We should instead exploit this instinct and go further and lean on the fact that people love solving puzzles. And let's indulge ourselves. Let's use the new shiny library. We can rip it off if it doesn't work out for us. Learning new things is exciting. This is what makes me as a developer happy. And if it doesn't work out, okay, we can refactor it easily. It's Haskell. If it was some other programming language, yes, you will be in trouble because, well, you cannot really rip it off, no way. But we have much better type system. We have much better tools at our hands. Same thing with like any leaking complexity. Yeah, it's maybe not too pleasant, but it's cheap to demote and dismantle complex type system in Haskell. You can basically always like remove all your dependent types and just get back to your Haskell 98. So it's year 2025, guys. We should really leave everything boring to artificial intelligence and jump on a new train of what I call actually puzzling Haskell. But what kind of puzzles are we talking about? So let's define the rules of the game. What kind of puzzles will excite us? Yeah, it's not, there is a big difference between puzzles and pub quiz, right? You're not supposed to know who won most Oscars 40 years ago. You're not supposed to know the answer to puzzles beforehand. Instead, while like experienced developers indeed will rely on instincts and insight to solve puzzles, yeah, instead, nevertheless, puzzles should offer some systematic way to attack them, yeah, without having extensive prior knowledge, without having to explore graph like breadths first. Puzzle solving should not be tedious, right? No one wants to solve a Sudoku sized of this room. So each puzzle should be something which you can like solve in a reasonable amount of time and without like, I don't know, it shouldn't require you more than one pencil to solve. So we strive to write as little code as possible. Yeah, and we should be able to look at our puzzle at a glance, yeah, and it shouldn't be like one part of my puzzle is here and another part of my puzzle is in Zurich, right? Everything should be available immediately. Long distance interaction is bad. Long distance interaction will make our puzzles unsuitable. Yeah, we should keep asking ourselves, is it really a puzzle? Because puzzle allows being solved in finite time. If it's not solvable in finite time, it might be art, it might be something else, but not a puzzle. So keep asking yourself if the thing you constructed is still solvable. Oops. Where I am. Solving process should offer a tight feedback loop, right? When you're doing Sudoku, you have feedback loop measured in like seconds. So both compile time and run time should be fast. Otherwise, it gets tedious. Otherwise, it's not something you are going to enjoy. And it's not fun to solve the same puzzle twice. If you solved it once, it should just keep working, right? Solutions must be robust and survive through any upgrades you throw at them. I will start unfolding this from the last point, because I think it's actually the most important one. How can we structure our code? How can we structure our solutions in a way that we do not have to solve things twice? So I think there is some tension here, which I see in production environments quite often. And I have an analogy for it. You see, like, fearless refactoring, yeah, is both a blessing and a curse in the following sense. On one side, yes, it's great that in Haskell you can swap your backend in a day, you can swap your front end in a day, you can change your core types, you can change any function you like, you can add arguments, remove arguments, and all this is going to be very well founded in type checker and other warnings from the compiler. But exactly because it's easy to accommodate any change, library authors in Haskell exploit this, and they will make breaking changes that they would never ever in their life attempted to do in a Python library, in JavaScript library, or in Go library. So it's kind of very funny that we in Haskell having such huge capabilities for refactoring, that refactoring is such an easy task in Haskell, we end up with endless cycle of breaking and breaking and breaking things. And applying this to build environments, I feel that there is a bit of an opposite tension there. In a modern ecosystem, it's easy to set up and protect a uniform, reproducible environment, like across all your organization, across all your, maybe even across your clients. You have Docker, you have Nix, you can pin down everything if you wish so. And what I see that people kind of indulge this maybe too much, and what's up with it? And end up in a situation where every step outside of this well-protected ivory tower is a problem. You are overwhelmed by what is going on in the real world. You're overwhelmed by the amount of changes because now they are all at once. I've been through GHC upgrades and ecosystem upgrades and stackage snapshot upgrades many times in my professional career. And I noticed a vicious cycle, okay, we are serious professional developers. Our environment is set in stone, Nixified or whatever you use for this. Okay, we wait to upgrade. Okay, we're not gonna pick up GHC 9.14.1 because 0.1 release is gonna be unstable. We will wait for 0.2, no, 0.3. Let's wait for 0.5 to be certain. Okay, we wait for a year. Then we wait for another year until stackage LTS snapshot is available. All right, we're already 2 years into this upgrade, and the last minor GHC release of that major series has already been shipped, right? So that we have some stackage LTS for it. All right, all good. We are serious developers. Let's try and upgrade. The problem is we are a small community, and everyone's configuration is very much different. It's very likely that your application will trigger some unique interaction in GHC and you will hit a bug. And if you've been lucky not to hit a bug, then probably a package you are using is missing from this stackage LTS. And since it's already stackage LTS, it's kind of difficult to put it back into it. It will be added to a new stackage LTS a year later, but not right now. So we say, okay, well, we'll just wait. We'll wait for another GHC release and do this cycle all over again. There is only one thing you can do worse in this situation. And it is that you probably, again, we are a small community. We don't really have long-term support for GHC releases. So sometimes if a major GHC release fixes a bug and you want this bug to be fixed in your environment, you must upgrade to a new GHC release. Or, and it's a very tempting proposition, you can patch your old GHC release, right? Backport it manually. That's the only thing you can do to make it worse in this situation, because it's even more unmaintainable at this point, right? The solution, which I think works quite successfully in teams I worked in, is actually that, okay, we keep our production environment set in stone, fair enough, but development environment is fluent. Yeah, I'm literally talking about using the very latest GHC release and packages directly from Hackage without any freeze files at all. You see, like, if there is an incompatibility, if there is a breakage anywhere, you will have to fix it. We are not hoping that our product will be decommissioned at some point. We still will have to fix this. So why not to fix it early, right? Worst case scenario is that if this is difficult to fix, if someone broke everything in the new release of their package, okay, we will just put in a Cabal upper bound, but at least at this point, we know the issue, we can track it, we can prioritize it, and we will resolve it much quicker than in 2 years, as in the plan A. And constant pain teaches you very quickly which parts of ecosystem and which parts of Haskell features to avoid. The result is that basically GHC upgrade takes days. So when a new GHC major release appears, it's possible to upgrade to it in a matter of a couple of days, right? And it's much, much better experience because now your developers have upgraded to the latest and greatest GHC. Okay, if they hit any issues, we can report them directly and they will be fixed in 0.2 release, not in 0.5 in 2 years from now. If there is anything missing from Stackage nightly, we can put it back, yeah, and we can be sure that it will be in Stackage LTS when that LTS appears. Yeah?
I was wondering, so is there a point where the development environment becomes a production environment, or the production, because like otherwise there's like no point, like also just like changing your development environment or delivering it. You know, at some point, like you actually want to upgrade the production environment, otherwise I don't.
Yeah, of course. You upgrade production environment when you have Stackage LTS in this schema.
I guess ideally at least one developer is running the equivalent production environment.
Well, you are supposed to have production environment somewhere, right? So, all right. So there are two parts of Haskell, features which I find not contributing to great puzzles. One part is, unfortunately, template Haskell. I'm very much excited to hear talks about stabilization efforts for template Haskell later on. But at the moment, template Haskell is a pub quiz. You're supposed to know upfront what's happening. Like, to give you just a small example of this pain, which is something I was actually involved myself, and that's why it hurts so much. Like in GHC 9.8, some template Haskell type called type variable binder, I suppose. Yeah, so some usages of this type changes from using unit to binder visibility. And if you have some amount of template Haskell code to support, you basically have no idea what just happened. Like, this is literally like what you saw in something like changelog. Okay, well, it changed. Okay, what I'm supposed to do about it? Not sure. My code just doesn't compile at this point. Yeah, I can go into headocs for these things, for type variable binder and for binder visibility. It says me not much. It basically says me that, okay, yes, flag can be unit or can be binder visibility, and binder visibility can be this and that. No documentation, no explanation, I'm stuck. That's not a puzzle. That's pub quiz. So that means that it's better to reduce template Haskell from my perspective. And don't get me wrong, it's not a cheap choice because you, for example, like you have problems with lens and with many other parts of ecosystem which rely on template Haskell heavily, but that's the choice I make at this point of the Haskell evolution. Another part which is to be avoided, again, from my perspective, is GHC plugins. Because everything which I told about template Haskell applies. Again, you have like fluid AST, you work with it raw, and it's similarly fragile and undocumented. So basically, if you hit an issue with some GHC plugin and it suddenly doesn't work, there is no like systematic approach how to fix it. Type checker will not tell you anything useful or anything documented at all. Yeah, and plugin is like a black box, huge black box. At least for template Haskell, I can try and read headers. And maybe I'll succeed eventually and try things. But it's black box, it throws some errors. I don't know how to support it unless a person who wrote it will be so kind to upgrade it. So you see, like, if the problem is reading finite amount of manuals, then it's fine. Like, if somebody uses like linear Haskell, okay, I will go and read a manual on template. If someone is using linear Haskell, for example, I can go and read a manual on linear Haskell. But if my GHC plugin is broken, I probably need to read potentially infinite amount of code implementing this plugin. And that's not fun, right? So these are two features which I would avoid in production environments. Yeah, and now we need to move to something positive, right? So how are we going to solve puzzles? And the idea is that you should structure your code in such a way that hole-driven development works for it. Yeah, hole-driven development is when you replace some part of your code with underscore, yeah, and you ask GHC, dear GHC, tell me what can be used here. Like, this is a systematic approach. Like, if I forgot anything of standard library, yeah, I just put underscore and ask what fits in this hole. And the way to make it productive is that you have to use as many fine-grained types as possible. If your type system, if your types which you use are fine-grained, then GHC knows much more about your program and is able to suggest you much better solutions. One thing is that I believe that the default settings for type-driven development are not quite ideal. Let me show you an example. So what we are doing here is that we import data monoid, and we have a list 1, 2, 3, and we ask GHC, tell me what can be here instead of this underscore, yeah, so that the result is of type some integer. And GHC says us by default, with default settings, GHC says, okay, you can substitute mempty. Which is perplexing on 2 counts. And first count is actually, is mempty even a valid substitution here? Yeah, unfortunately, there is a mempty of function type, right? Which will basically ignore its argument completely and will return mempty of the result type. That's an example where having ad hoc polymorphism is not so helpful. But anyways, even if I didn't suppress the type signature in the previous slide to have a small question, even in this case, well, GHC suggestion is absolutely unhelpful here. Certainly, we didn't mean to write mempty there, right? But there is a setting. What's up? There is an interesting setting that you can set refinement level to 1, and GHC suddenly will generate not only like first level of fits, like immediate fits is something like mempty, right? Which you can replace underscore with mempty. But it will also try to generate refinements, yeah, so that like it will say, okay, maybe you can put const with something, not really. Or maybe you can put fold map with something. And I think fold map with something will do, right? What will be this unknown something? Yeah. What I can literally do Yeah, I don't really have to ask anyone about this. What I can literally do, I can just copy this. I can just copy this part instead of underscore and run GHC again, asking it to resolve this hole. And it will tell me that, okay, yeah, there is one obvious solution, immediate solution, just say sum. Now, again, I'm not saying that we shall use hole-driven development every time, but this is a useful approach to estimate whether your code is maintainable or not. If your project, if structure of your project, if your data types allow you to use hole-driven development, then you're fine. Then you have good puzzles there. If not, then you will be in trouble whether you use hole-driven development or not, right? So core rule here is that we shall avoid features which weaken type inference, and we shall have as many fine-grained type as possible. Yes?
What do I do if hole fits take too long to load? Because I have disabled them in the past because it takes just so long.
Well, then what do you think will happen in your mind? Your mind is doing the very same job that GHC does there. It means that
Well, my mind has slightly more information, maybe, I don't know.
if you literally have like hundreds of whole fits, then you will have trouble with thinking about all of them on your own. You probably need to use more types. Probably you need more fine-grained types so that there are less fits. Yeah, so what I want us to remember that we should avoid features which weaken type inference. It's fine if we use dependent Haskell. It's fine if we use linear Haskell. Yeah, they are not weakening type inference. They're actually making things better in this framework because they actually make types more fine-grained and make hole-driven development more useful. Right. So we have like 150 language extensions, and let's go one by one. Okay, we're not gonna do that. Yeah. So just doing a quick tour through language extensions. Like any syntactic extensions in the framework of puzzling Haskell are great. They allow us to write less code, which is good. Which helps us to keep us focused. If you don't know some particular syntactic extension, you can indulge your curiosity and read the manual. Manual is short and sweet, and you'll be excited to learn a new thing. Record extensions are fine mostly. The only exception is like record wildcards, because it basically is name shadowing. With record wildcards, you had an identifier on one type, and suddenly in some scope, it has completely different type.
But you get the same name shadowing warnings. So if you don't like name shadowing, this doesn't suddenly seem to be enabled.
That's true. Is it?
Yeah, I use this.
All right.
It helps if you have no field selector.
All right. Any deriving extensions of any sort are obviously great, saving boilerplate. Safe Haskell is too fragile in my experience. I would avoid it at all costs, but also I don't think I ever saw Safe Haskell used in any industrial code base, to be honest. And overloading things like overloaded strings, overloaded lists, according to our framework, they harm type inference, so they are undesirable. Yeah, we can just look at the very same example we just analyzed with underscore and the list of integers. What will happen if we enable overloaded lists? So now GHC is completely puzzled. It cannot give us any useful suggestion at all. It says like, well, maybe you want mconcat, sconcat. It's just basically throwing at us some random functions from Prelude, essentially. Right? None of it fits even in any way, and it also gives us two errors saying, oh, you have ambiguous type variable arising from overloaded list prevents constraint list from being solved, arising from literal. That's too much for me. These two errors is exactly that. Basically, type inference became too weak. And that's why I would avoid overloaded list as much as possible. Speaking of type system extensions, so like GADTs are kind of double-edged here. Like on one part, they make your type system more fine-grained. Yeah, so you get more useful whole fit suggestions, but they also make type inference in some cases a bit fragile and worse. As we discussed just now, like type-level programming, dependent Haskell, great. No problem with that, as long as you avoid template Haskell and GHC plugins. Yeah, because we often rely on template Haskell like for singletons library or anything like this. Yes?
Did you maybe I missed this, but did you mention overloaded strings also? Because, I mean, I think it was a similar argument to overloaded lists, but on the other hand, I've never worked in a code base that doesn't have overloaded strings in it.
It's, let me return to this question in a moment. Yeah, so like you see, I'm very much I'm very much not proposing to do any simple Haskell here. Like I'm very happy with dependent Haskell. I don't believe it's a problem in an industrial code base. And any type refinements, any like all these fancy type level things, they are actually very easy to remove from your code. If you suddenly decide that no, you want Haskell 98, okay, you just rip it off entirely. And most of the time, things just keep working. Yeah. Ad hoc polymorphism.
Sorry, before we move on. How do you efficiently use the singletons library without template Haskell?
You don't use it.
Okay. So you just write all the instances by hand?
Yes, if you must.
Right.
Well, I mean, it's really like a question of whether you can pull off dependent Haskell without singletons library. But you can.
What do you think of the pattern of just contain the spread, the scourge? Create a standalone package module, give it some build rules, and change it as unoften as possible and then depend on it.
It could work, I mean.
But if it depends on template Haskell, when you bump your GAC version, you have the same boundary problem.
True enough,
Yeah,
yeah.
so I'm going to attack the most core feature of Haskell. I'm going to tell you that you should resist the urge to introduce a new type class. The only thing you have to resist even more is introducing a type class with an associated type family.
I've been thinking about this the whole time you've been talking. Type classes.
Yeah, ripping, like, I very much understand that type classes are bread and butter of Haskell and great feature. Unfortunately, ripping off badly designed type class is a major undertaking. And we can actually get back to the question why overloaded lists are even worse than overloaded strings, because overloaded lists are implemented via type class with a type family. Yeah, because that's what basically made GHC to struggle in our earlier example. You're basically saying, okay, like anything goes, like any type L and with some item L, and then to list just works and from list just works. You're not giving GHC any meat to chew. Like it just says, okay, I don't know either side of equation here. I don't know right-hand side. I don't know left-hand side.
Do you have the same opinion about injective type families?
It's a bit better. It's a bit better, but you can also be in trouble with them. But it's better, yes.
What about mono-traversal?
Honestly, never used mono-traversable in my life. I don't even know what it is about. Somehow, like it's a very common thing with junior Haskell developers, and I've done pretty much exactly the same what you can see on this slide. Yeah, we are being taught that type classes are cool, and every time we see something which can be generalized, we think, oh, maybe we should introduce a type class. And very quickly you introduce something like this. Oh, let's introduce consume. It will take two parameters. Sorry, I actually misspelled this slide, but I think you'll get the point, which will depend on its argument to what we are consuming and how we are consuming. And this will be such a wonderful type class which will take what and how and return an IO unit. Right, and we'll have instances like you can consume soup with a spoon, you can consume steak with fork, and car can consume petrol, and folds can consume streams. Very useful abstraction, right? And then our code base is full of such over-generalized functions which just take some type class consume and stuff. And at some point, we don't really know what is what and how is how. And it's very difficult if our code base is structured this way. It's very difficult to rip it off at some point because you will have to redo lots and lots of work and decipher what exactly are the instantiations of this full function. So don't start doing this. Go with monomorphic functions. Only if monomorphic functions are that terribly painful thing that maybe you need a type class. But don't go for it as a first option just to generalize things. This is probably the biggest trouble I saw in production code bases when you have a mess of type classes and open type families, and no one really understands what is doing what. Right, quiz time. Is this a correct program? Will GHC compile it? No. No, we are just running GHC on this file.
You're shadowing log from prelude.
I'm not even shadowing, right? GHC will immediately say that it's ambiguous. It will not be a name shadowing warning. It will be just an error.
There is a proposal for the import shadowing.
Yes, exactly. That's what I meant to say on my next slide. So we are lucky to have a proposal to bring GHC into census, yeah, because it's quite obvious what kind of log I was meant to use in this context. It should be just a warning that yes, you are a bit sloppy. You are using. There is also log which is an arithmetic log, right? But it shouldn't be an error message. And this is a very fragile part of Haskell ecosystem at the moment, because basically anytime you imported anything unqualified, you can be broken by unrelated update, yeah, because underlying library just added a new top level function which happens to coincide with your top level function. Real world case was a couple of years ago when ASON library for JSON parsing, right? It imported data byte string for doing something, and it was not cautious. It was data byte string builder or something like this. So not the main module, but the builder module, which doesn't really export that many things, and it's often imported unqualified. Absolutely fine. The problem came probably 10 years later. The code was written when that builder module in byte string added a top-level identifier for scientific notation. And ASON happened to have function called scientific on top level as well. And that's been absolutely unexpected breakage just because someone added an identifier. So I'm eagerly awaiting this new extension called import shadowing to be merged, because it will make our ecosystem much, much more resilient to such unexpected breakages. Until it arrives, always use explicit. Export lists, strongly prefer to use qualified imports and explicit import lists. Yeah, and do avoid hiding clause because it will give you a warning at some point if that identifier or entity is moved away, even if it entails basically no implicit prelude, which is painful, but better to avoid, to be on the safe side and to not be fragile because of some imports changes. It's not that bad if your library is broken because of some substantial change. But it's very annoying when your library is broken just because of import lists are clashing or something like this. So better be safe. One small quality of life thing, probably pretty much everyone who upgraded to GSC 8.10 can use import qualified post language extension, which makes your imports much more neater. Yeah.
I just wanted to say a comment about especially the different rules apply whether you were working on a library that goes to package that other people use, whether you're working on an actual product, an actual computer, because then, for example, using hiding is absolutely acceptable because eventually if it breaks on a newer LTS 90 or whatever, then it will be fixed. And it's not going to affect the production. But if you're working on a library, I totally agree with you.
Yeah, makes sense. Yeah.
Where do package imports fit into this?
Sorry?
Package imports?
Package imports are fine, no problem with that. I don't use them all the time. I think it's a bit too verbose for my taste, but I don't think it's a liability. Moving forward, quiz time. What's the result of this program? What's the result of function foo? We define a small data type of infinite lists, right? Which is like usual lists, but simpler without empty cell constructor. Yeah, and we define like this thing, like this is an infinite list, and then we pattern match on it and extract the first element. What's the output?
Depends on the extension.
No, it depends on the
I'm not really sure. It depends on indentation here, but I can take any answer. What are numbers which this function can return? One. Fine. Yeah, and now your coworker moved this function to another module, and now it freezes and doesn't return one at all. Why? Huh? Strict data. Yes, exactly. If you move this function to a module where strict data is enabled, suddenly your infinite list, all arguments of constructor became strict, and now your construction of XS will just freeze.
But it's almost as if GHC intentionally sets you up to failure because you can't use the tilde syntax for lazy field unless you have strict data turned on. And likewise for banks, for strict fields, unless you have strict data turned off. So you can only use the default or the other one, but you can't explicitly say I want what would otherwise be the default so that you can read it.
Yeah, that's a good point. I mean, conclusion from the framework of which we are trying to build here is that it's bad puzzle when enabling an extension changes semantics of your code. It's fine if code doesn't compile without extension and compiles with or otherwise, but if flipping an extension just silently changes runtime behavior and semantics, that's a bad extension. So do avoid strict and strict data. Instead, it's a bit tedious, but you should use banks when you declare your data types. And it's very important that you make invalid laziness unrepresentable on the data type level. I think I'm stealing this quote from Tom Ellis. Yeah, because it prevents further issues. It's very difficult, like, to find a laziness leak in the end application if your underlying data types do not have proper banks in all proper places. You can obviously use like bank patterns in functions. You can throw deep sec at your arguments. But all of this is basically you're trying to fix some symptoms. You're not fixing the underlying cause. And you will keep solving this problem over and over again until you make invalid laziness unrepresentable in your data type. So basically, ideally, you don't need strict data, and ideally, you almost never need bank patterns unless you should declare your data types with correct laziness annotations upfront. Yes.
But then you need strict maybe and strict vector.
Well, yes. If you need strict maybe, you need strict maybe.
You need to have it in base.
Right. I keep clicking in the wrong
But
place.
there's
Yeah.
the cultural aspect of this as well, because if I see code that uses like strict field type somewhere, my first thought is not going to be, oh, the person who wrote it was thinking, okay, you should make your laziness unrepresentable. I was going to think, I should pay attention to this because there's some tricky performance profile that requires these specific field strictness annotation.
I don't know, it depends on the culture.
Yeah, exactly.
Like, I got myself to a point where I put banks in data constructors subconsciously and first.
I mean, another related point is that every time I see a strictness annotation on a field that is of list type, for example, I'm not thinking that somebody prematurely sprinkled strictness annotations, but that somebody doesn't understand the way strictness annotations work. Yeah, I mean, I think this is an indication for me to go talk to that person whether they actually have an intent that is not actually realized by this. And so I don't know. I mean, I don't know what the real solution is, to be honest.
All right, we are getting close to the final slides. Generic programming, like as we discussed, like template Haskell is too fragile and you will have to solve your puzzles over and over again. It's a pity because template Haskell for generic programming and boilerplate generation is actually probably the best solution in terms of good compile time and good run time. They are both predictable and they do not degrade. Depending on the size of your data types, they do not degrade like as generics do. Scrap your boilerplate is unfortunately extremely slow in runtime, especially if you have like long chains of thunks and anything production grade. So at the moment, generics like GHC generics are probably the best choice from my perspective, simply because they are unlikely to be broken anytime soon. But with generics, you have a choice. You either have bad compile time when GHC is working hard to inline everything and all your 100 of record fields together, or you have bad runtime if GHC failed.
This is not
Yeah, so I'm very excited for template Haskell to be more stable so that I can switch my recommendation to the very first option. Yes.
Scrap your boilerplate, is that data not data?
Yes. Yeah.
I was under the impression that Haskell has issues because it can run I/O and compile time, and in principle, a third party building someone else's code could end up having malicious things executed in there.
Yes, but that's not immediately a concern of framework we are discussing here, right? I'm not penalizing it because you can inject something insecure. Yeah, I'm mostly penalizing it just because of stability issues and solving same things several times. Right. Old but gold. I did use CPP to generate boilerplate more than once, and actually it works probably better than any other option. So maybe it could be a solution for your use case as well. All right. We reached the final slide here. There was a discourse topic discussing slogans for Haskell, and I think this one very much reflects what I think about Haskell and what the proposed framework is about, that Haskell should grow with you, and Haskell is not a place or a language to restrict yourself to some limited set of features. Indulge your curiosity and have fun with this beautiful language. Thanks all.
Yeah, let's thank Andrew. So we do have time for some questions. I'm gonna kick off a quick survey here. So I've heard of other folks using Haskell, industrial Haskell, that also do this kind of, their dev environment is using GHC head and they're testing things constantly, and their production environment is much more conservative. Just a quick show of hands, is that how you all operate? Yeah, one handful. Okay, so it's not zero, right? Okay. So that's good. I don't think that you all work together. Maybe that's, but yeah. Okay, questions. Yeah, I'll let you choose the questions.
So, have you thought about how the existence of AI coding assistants and LLMs and things like that affects kind of any of the conclusions that you came to? For example, whole-driven development is to a large extent replaced, I think, by coding systems. So,
I'm very much excited. There was. The question is, what can we say about AI developments related to whole-driven development? I think there was recently an announcement of some AI-driven whole-driven development on Reddit of some plugin, but I have not tried it myself yet.
There's a talk on it later.
Awesome.
Like 90 minutes, yeah.
Awesome. I'm excited. I think that's great. I think that's finally something what AI is for.
Sorry, just to follow up, is there anything else that has changed, do you think, as a result of having AI available?
I'm not sure. I'm afraid that with more AI we will have, it will make it easier to produce lots of code, which is hard to maintain. Yes.
I agree with like whole-driven development, type-driven development, but I think the problem one of the problems brought on by the discussion on simple Haskell is that when you want to introduce more type guarantees, you have to introduce lots of language extensions and so on, which are quite opaque to new users. And again, with the strictness issue, having to think about laziness and how to approach it and how to control it from the user level is not really easy for a beginner. As you said, people might try to use bands inside the list constructor and so on. So I feel like the surface syntax is lacking from a usability perspective when it comes to introducing new people to more dependently typed Haskell. So, yeah, I don't know. It's more like an open question of how much are we like trying to patch it up until we end up thinking that, okay, maybe we should move to a language which actually is dependently typed and was built this way.
The question is whether we should, as far as I understand, the question is whether we should try to patch existing Haskell, existing GHC Haskell up to the dependent Haskell game, or shall we just invent a new language which will not have all these legacy restrictions? I think first time this question, I saw this question discussed was like about 12 years ago, right? And the answer remains the same. Like it's quite easy to experiment with dependent types in limited setting. It's very difficult to bring it into production, and probably Haskell is one of the best vehicles to see how it scales and whether it can actually be used to produce better software. There are other languages and other competitors in this area which are also very, very much viable indeed. Yes?
I have a much more concrete question. So if we can't use, or like shouldn't use type classes, how do we do interfaces with multiple implementations? So like what's your take on, say, record and functions pattern? When we have a record and there are functions and we use multiple instances of that record type to pass in possible implementations for certain interface.
Well, you cannot avoid type classes in Haskell, right? So my point is to resist the urge. But at some point, yes, you will introduce some custom type classes. That's okay. But really, really think hard about them and don't do it on a whim. Yeah?
Let me just understand correctly. So is the argument against template Haskell mainly because it's hard to fix the code when the interface changes, or the interface changes too often?
I guess both. The argument against template Haskell is that it's not making a good puzzle. Template Haskell is a pub quiz where you're supposed to know up front and have an infinite amount of wisdom about all template Haskell structures.
Sounds like a documentation issue.
It's not only a question of documentation, but it's also a question that I have to read all this documentation and remember it by heart. Yeah.
Just a follow-up. Do you see such a workflow maybe help a little bit, which is what I do sometimes is you comment the desired outcome, the code, near where the template Haskell is written, and when the interface may be broken or changed, you feed that the Haskell code and using the quasi code or whatever to see the general how the AS should look like. Then you go fix the code. So that basically my experience of fixing the code. The template Haskell code is not that difficult, but I have to do the upfront work, which is in the comment put the code, so that later I can reuse it and see how do you see that workflow can help?
It could help in some cases, indeed, if you just quote as far as I understand, you are saying that you can quote an expression and see its AST and then try to amend your template Haskell generation. To some extent, yes.
Help to solve the puzzle.
To some extent, yes, but you will still have to solve it over and over again.
What's the difference between overloading string literals and overloading numeric literals? I don't think anyone is advocating against numeric literals being overloaded.
I think you have your answer.
No, but seriously, like in your opinion, like what is the difference there? What makes string literals overloading more problematic?
I think like there was a slide where you said that like the problem with overloaded lists is that it involves flat counting.
Yeah, but again,
yeah.
So that's not, is it defaulting or like what is it?
I think I had enough troubles with -1 of unsigned integer type in my life to hate overloaded numeric literals as well. I mean, all of this is kind of grades, right? Something is worse than others. I'm not saying that you absolutely never should use any overloaded lists at all, right?
Yes. All right. Let's thank the speaker again.